when we were going to study the states of matter in when we're going to study the matter in its gaseous state, three physical parameter is required for us to mention that physical parameter, three physical property is gas, volume of the gas, pressure of the gas, and the temperature of the gas. Now volume of the gas is measured in the unit of liter, milliliter, centimeter cube, decimeter cube, and millimeter cube. There is a few relationship between these units that we need to remember during the mathematical problems. That 1 liter is equals to 10 to the power 3 milliliter, ml equals to 10 to the power 3 centimeter cube equals to 1 decimeter cube equals to 10 to the power minus 3 meter cube. The pressure of the gas rises when the constant particle collide with the wall of the container, and it is measured with the help of a device known as barometer. It is found that the uh, the pressure, atmospheric pressure at 0 degree Celsius is equal to the 76 centimeter height of an mercury, the pressure exerted by a 76 centimeter column of mercury. So this pressure is given a specific name known as atmospheric pressure, and this has become the unit of pressure, atm, atmosphere. So 1 atm is represent 76 centimeter of mercury or 760 millimeter of mercury, or in another unit 760 torr. There is another unit of pressure, that is Pascal, which is 1 atm equals to 1.013 into 10 to the power 5 Pascal. Another unit that we need to memorize is bar. 1 atm equals to 1.013 bar. Now this is the units of pressure. To measure the third property of gaseous substance, that is the temperature of gas, the temperature is represented in the form of Kelvin scale, and it is found that we can transform any temperature from centigrade scale to this or Celsius scale to the Kelvin scale via this expression: T degree Celsius equals to 273 plus T Kelvin. Now these are the three physical property: volume of the gas, pressure of the gas, and temperature of the gas is the three property, and along with that the number of moles of gas, the numbers of particles present in the gas. These four property defined any state of the gas, define the actual all the properties and the relationship of the actual state in which the gas is existing. That's why in the future, when we are going to talk about study about gaseous substances and how they function in nature, we are going to take the help of these four parameters. It is found that all gases, irrespective of what kind of gas, to some extent follow some laws. These laws relate the physical properties of gases, that are volume of gas, pressure of gas, temperature of gas, and number of mole of gas. The first law in them that we are going to study is the Boyle's law. Boyle's law relate the pressure of gas with the volume of gas. As when we are going to study the parameters of gas, two parameters of gas, we need to make constant the remaining two parameters, that is temperature and the numbers of mole. That's why during the study of Boyle's law, constant temperature is taken and numbers of mole are constant. Now when I'm saying that numbers of mole of gas is constant, that means I'm saying about a closed container. We are studying this entire law, we are observing this law in a closed environment, because if the open environment is taken, then the numbers of moles of gas will change by exchange with the surroundings. But with closed environment, the numbers of gas that we had taken will remain closed throughout the observation. That's why Boyle's law, these observation occurs, the Boyle's law is applicable for closed environment at constant temperature. So what is the statement of Boyle's law? It is saying that at constant temperature, the volume of a certain amount of gas is inversely proportional with its temperature. Meaning, let's say that V is the volume of the gas, and it is Boyle's law saying that it is inversely proportional with the pressure of the gas. If pressure increases, then the volume of the gas will decrease. If you increase pressure on a closed a certain amount of gas in a closed environment at constant temperature, the gas will contract, the volume of gas will decrease. And if you if you decrease the pressure of a certain amount of gas in a closed environment at constant pressure, in that case the gas will see an expansion. We will see an expansion of gas. We will see that the volume of the gas increases. Now, this is the mathematical expression of Boyle's law, that is V is inversely proportional with the pressure. V proportionality sign 1 by P. Now, mathematically, to replace this proportionality sign with equal sign, we need to multiply n constant term, a proportionality constant k, with this equation, and thus the equation become V equals to k by P, or the equation can be represented as Vp equals to, or Pv equals to k constant. This is another form of Boyle's law expression, mathematical expression for Boyle's law, which is saying that the product of pressure volume at a constant temperature for a certain amount of gas will not change. It is constant. As it is constant, even if I change the pressure by increasing it or decreasing it, the volume will change in such a way that the product of volume and the product of the resultant volume and the resultant pressure becomes equal with the product of the pressure volume previously. This is the law, Boyle's law, mathematical expression for Boyle's law. Now, this can also be represented as, supposedly, a certain amount of gas at T Kelvin temperature is taken, and the pressure and volume is found to be P1 V1. At that particular T Kelvin temperature, that certain amount of gas changes the pressure to P2. So obviously the volume will be also be changed to V2. It is found that according to this one, you can write that P1 V1 equals to P2 V2, because the temperature is constant, the certain amount of gas you have taken in a closed environment. So whatever the change the product and the pressure and the volume may be, the product of pressure and volume will always remain same. That's why the product P1 V1 is equals to P2 V2 when temperature and numbers of moles is constant. Boyle's law can be explained on the basis of graphs also. Now, let's try to establish a graphical plot for P versus V for Boyle's law. Now, any graphical plot is drawn on the basis of some equation. Now, there are 2 or 3 Boyle's law mathematical expressions that we have just studied. We need to take the help of that specific mathematical expression for Boyle's law, which is representing pressure and volume. Now, separately, pressure and volume is represented in the P equals to K by V plot, where P is the P is taken in the y axis and V is taken as the x axis. So clearly you can see this expression is equal to the equation y equals to k by x equation. Now this equation represents the graphical plot which is an exponential type graphical plot. So P equals to K by V plot is going to be an exponential type. What this means? This means that when you're moving along the V axis from right to left, the volume is decreasing, and with the decrease in volume, the pressure is increasing simultaneously, and at a certain point, with the increase in volume, an abrupt increase in the pressure can be observed. This is what this plot is suggesting, and this plot is drawn at constant temperature for a certain amount of gas taken in a closed environment. Another plot can also explain Boyle's law, which is PV versus volume plot. Now, to draw PV versus volume plot, in the y-axis, I am going to take the PV, and in the x-axis, volume is taken. So the x-axis is volume axis, and the y-axis in this plot is PV axis. Now the mathematical expression that will help to draw this plot is the PV equals to K. This Boyle's law expression, where PV, the product PV and volume is represented. Now we know that PV product is constant. So whatever amount of change of volume I will do, the product will remain same. So this will give a straight line equation, a straight line plot which is parallel with the volume axis, meaning that with the decrease or increase in pressure volume, the product PV is not changing, and this plot also is taken at constant temperature. Let's try to do another plot. This plot that we are going to study is of the type pressure versus 1 by volume plot, meaning we need to take pressure in the y-axis and 1 by V in the x-axis. So the x-axis is 1 by V axis and the y-axis is pressure axis. Now the mathematical expression that will help us to draw this plot is PV equals to K by V. This Boyle's law expression, in which P is representing the y-axis and 1 by V is representing the x-axis. 1 by V represents the x-axis. As you can see, this is nothing but a straight line equation starting from origin. Straight line equation starting from origin. So the plot will look like this. Straight line equation starting from origin. Now, starting from origin, I have drawn the initial part in a dotted line, and after a certain point, the main straight line is drawn. Now, why this dotted line in the initial part is there? Because this origin represents zero position, meaning zero volume, 0, 0, 0. That is 1 by V is also 0 and P is 0. That is, there is no pressure at that point that is exerted by gas. And also 1 by V is 0, meaning V is infinity. That is, the volume of the gas has expanded so much that it has reached the magnitude of infinity, which is hypothetical in nature, cannot be attained in real. So this plot is real after a certain value of 1 by v and p, that is this value. After this point, this is a real straight line equation, but below this point, this is a hypothetical plot, not a real plot. Let's try to do another plot. In this one, we will try to study log of PV, log of P versus log of V plot. To construct this plot, as you can see, it is log of P versus log of V. That means we need to take y-axis as log of P and v-axis as log of V. So the x-axis is log of V and the p-axis is log of P. Y-axis is log of P. To draw this plot, we need to take help of the P equals to K by V expression. Now I am going to take log for both the side. Log of K by V or log of P equals to log of K minus of log of V. This is the constant term. Log of P is y minus 1 log of V, which is x, plus c. So this is a straight line equation with a negative slope. So the plot will look like this with a negative slope. So this is how the graphical plot can explain the Boyle's law. Or you can plot different kinds of plot from the expressions of Boyle's law. Boyle's law relates the pressure of gas with the volume of gas when the temperature is taken constant at a closed environment. Now, when this Boyle's law was observed in a real life situation, it is found that most gases obey Boyle's law only at a very high temperature and at low pressure. In fact, hydrogen, nitrogen, these kind of gases to some extent obeys Boyle's law, but carbon dioxide, ammonia, this type of gases shows deviation, huge amount of deviation from Boyle's law. But still we need to study Boyle's law because it gives an empirical idea about gaseous substance, how they behave with the help of their physical properties. Now, from the Boyle's law, which relates the pressure with the volume, another relation can be extrapolated between the pressure of the gas with the density of the gas. Let's see how. The Boyle's law says that P equals to K by V. P equals to K by V. We know that density D, density of gas D, can be represented by mass of the gas by volume of the gas, or volume can be written as equals to mass by density. Now, as we have taken we are observing this law in closed environment. We have taken the numbers of mole, the amount of gas constant, therefore the mass of the total mass of the gas is going to be constant. So the aim is constant for this Boyle's law observation. So I'm going to replace the V in the equation with m by d, where I can write P by D equals to K by M. Now K by M, K is proportionality constant, and for this observation the total mass is also constant. So K by M is constant. So I can write P equals to K by M multiplied D. That is, by removing the proportionality constant or constant term, I can write P directly proportional with D. That is, the pressure of gas is directly proportional with the density of gas. If you increase the pressure of gas, the gas will become more dense. If you decrease the pressure of the gas, the density of gas decreases. Or you can write P1 P2 equals to D1 D2.